Alright, so today's work is on 2.2.2 for Apex Statistics. This unit is really, again, kind of like sort of definitions and some plots. So we'll go through some of this so you can get a general idea of what you're doing. The quiz had some work with the difference between numerical data and discrete data, so there's questions on that. And then you just have some like stem and leaf plots and those type of things that'll ask you about. So they're hopefully pretty simple, and they actually follow pretty closely with this one this time. So for question 1, it says determine which of the following are numerical data. So numerical data are anything that can be counted with numbers, basically. It doesn't matter what kind of numbers, it's just any numbers. So anything that is with numbers, numerical data. So if we look at question number 1, it says which of the following are examples of this numerical data. Well, you just want to read through each one. There's multiple answers here. The number of black jelly beans in a jar. Well, can you count the number of black jelly beans in a jar? Yes, that is numerical data because it has a number. It's 50 black jelly beans in the jar. Whatever it is, it can be counted. The heights of all the high school basketball players. Well, can I count them? Can I measure every basketball player, right? He's 6 foot, he's 5'8", he's 6'3". Those are all numbers, they're all measurements. So yes, I can count the heights of the basketball players. Favorite colors of all freshmen. I hope this is pretty obvious. Colors are not a number. I can't count the colors. I'm asking them a question about what their favorite color is, not an amount. So no, that is not numerical data. Each time a student spends, the time each student spends standing in the lunch line. Yes, that can be counted. Maybe you spend 5 minutes, maybe you spend 2 minutes. It's however long you're in that lunch line. That is a number. Time is something that is measured in numbers. Okay? So those would be examples of numerical data. Weather is numerical data, so those type of things. Discrete data, this is like whole number counting. For discrete data, it has to be a whole number, okay? So you can't have any decimals. So if we go back to number 1, the height of all the basketball players, well, basketball players can be 6'3". That 3 is a decimal. That makes it uneven for our count. So the height can't be counted in this sort of way. The number of jelly beans in a jar, that can be counted because it's 1, 2, 3. We don't have half sizes, 4, 5. It's just whole numbers. The amount of students in a classroom is another example of this. I can't cut any of you guys in half. You all are whole numbers. That's the only way I can count you. So discrete data is all about that whole numberness, right? So if we look at these answer choices, the number of errors committed each season by a baseball player. Well, if we think about it, player really screwed up that season, had 8 million errors. I can count those errors. 1, 2, 3. You don't get flagged half of an error in baseball. You get a whole error. The time it takes to sing a song. That cannot be counted. If you're thinking about singing, right? This video right now is at 4 minutes and 20 some seconds. That's odd. That's awkward. I'm not counting that. Okay? The number of questions on a quiz. I know all of you go straight for how many questions are on it. How long is it? And you know right away, well, it's 10 questions. That's how long it is. Okay? So yes, that can be counted. And the distance each student can run in 12 minutes, you're all going to run different distances. And they're not distances we count. We'd have to measure it. You went 1.2 miles. Something like that. Like, that's awkward. We can't actually count that. We have to measure it. Okay? All right, so this little chart here is a frequency distribution. What you see here is the exercise time and the count. So we asked people, when do you exercise? Is basically what this is happening. Morning, there's 146 people. Early afternoon, late afternoon, evening, you see the number of people who said that that's when they exercise. So for number 3, it says how many people were surveyed. Do some addition there, add them up, you'll get your answer. Okay. I won't spend time adding up. Just add up the morning, early afternoon, late afternoon, evening. If the data was represented with a dot plot, so if you don't know, a dot plot looks something, you have a bunch of dots, it's like that. So you collect your data that way. Okay. Which period of time would represent the smallest number of dots? This is something that you will be asked on your quiz. It'll be like, which one of these numbers would represent the tallest dots or the smallest dots? It's really easy. Which number is the lowest number out of these? Morning's at 146, early afternoon is 123, late afternoon 84. Oh, and look, evening's 47. So 47 would be the smallest. So we have morning, and then evening would be the smallest. So it's just the lowest number. If it asks about the tallest, that's the biggest number. Tall, big, shortest, small. Okay. This right here is an example of a stem and leaf plot. The way a stem and leaf plot works is you have this number in front, the 5, and then you have a line, and then you have the numbers after. So this 5, 2 means that that person got a 50, come on, a 52%. Okay, and you see this key over here, 6, 4, well that's a 64%. So you can do this with any of these numbers. 7, 0, they got a 70. 8, 9, they got an 89. So you can see it all breaks down. All right, so the first question is, how many students took the Chapter 9 quiz in Mr. Smith's algebra class? Well, once again, what you want to do here, ignore these numbers, ignore this side right now, okay? Just count. You have the 2, 8, so 1, 2, just count how many numbers are over here. Don't count them, let them like add. So it's not this first line is 10. That's a 2 and an 8. So there's 2 numbers there. This line is 2. 1, 2, 3. This line is 3. So you count the number of numbers in a line and then add them up. I hope that makes sense. Let me erase this scribble. So just count out the number of numbers that are over there and add them up. Then it says, what is the difference between the highest score and the lowest score? Well, the highest score would be in this 9 category, and I want to go to the biggest number. So somebody got a 99. Lowest score, I want to go to my 5, and the smaller number there would be the 2. So you can go ahead and do that subtraction on your own. All right. This one is an interval. It's not so bad. So you want to split all this data into 5 groups. This is snowfall. Okay. Oh, that's crazy. Where do they live? We're getting any snowfall in June, but that's a different story. So anyway, so this is snowfall in inches that accumulated. So what you want to do, it says 5 interval groups. Come on, why aren't you doing what I want? There we go. Okay, so 5 interval groups. What I want to do is find my lowest number, which thankfully is easy, 0, and my highest number, which in this case would be in December, that 14.5. When we do an interval group, though, we want to have whole numbers, okay? So I need to round up. So my interval should go from 0 to 15, right? So I have 15 different spots, basically. So when I make an interval group, I need those spots to be even. And I want to have 5 groups of data, which means I would take my 15 and divide it by 5. Okay, 15 divided by 5 means I'm getting three per group. Okay? So if I look at this in my answer choices, no, I'm good. My first one here, 0 to 4. Well, that's 4 because it's going all the way up to 4. 4 groups in one. I don't want them. I want them evenly distributed, so I can't have 4 there. And this last one only is 2, 13 to 15. So that's too much of a spread. 0 to 3, on the other hand, that's my 3 groups. 4 to 6, so 4, 5, 6. Again, there's 3 in that group. 7, 8, 9, there's 3 in that group. 0 to 2, well, the next one, that's only 2 things in this group. So we can see that we want to break, and it only goes up to 10, so that's too small. And this one only goes up to 13, so that's too small. So the only one that works for my purposes come on. Is this one. So you want to look at, it needs to start at 0, which they all did, and it needs to end at 15, which only these first 2 did, and then it's a question of which one breaks it down correctly. I need to have this to be 3 per group, so this 0 to 4 is too many per group. Then it asks for the intervals and frequency. So what you do, you have these intervals over here. You would fill in 0, 3, 4, 6, and you just copy down what you circled. And then you count how many. So how many had 0? Well, here's 1, 2, and to 3 inches. Here's another one, 3, here's another one, 4, 5. I think that's all of them, so I put a 5 here. And then you do that for the other groups. So you want 4 to 6, find anything between the 4 and 6 range. Still can't believe this place is getting snow in June, but whatever. I guess it's cold there. Now it says use the comparative stem and leaf plot to answer the questions. So the stem and leaf plot, you're just comparing. So the first side is your low temperatures. So just make sure you read through and high temperatures because some questions will ask about high and low, and you'll see that when we get to your apex. So what is the average high, or what is the highest average temperature? So I'm on the high side. I want the biggest number. Well, 8.3 looks to be my biggest number. And I'd be down there. And then it says for how many months, okay, is the average temperature low 30s? Low. I need to be on this side if I'm talking about low. 30s. I want to find my 3. I'm only caring about the one side, so I count how many times 30s happen. So I have 30, 32, 37, and 37. So that's 1, 2, 3, 4. And my answer would be 4. I think the quiz pretty closely matches, but if you have any questions, feel free to email me or get on Teams, and I'll help you guys out. I hope you have a good week.